welcome to today's Explainer. I'm putting on my senior facility engineer hat today because we are tackling a massive infrastructure dilemma that honestly keeps a lot of data center designers awake at night. We're looking at the critical routing pathways right above your server racks. We're talking cable management, specifically tearing down the differences between two light-duty heavyweights and how they actually perform in a data center environment. So grab your hard hats and let's get analytical.
So, wire mesh or perforated tray? Which one actually wins out in the data center? If you've spent any time at all designing or upgrading a facility, you already know that every single design choice is a fundamental trade-off. There's no magic bullet here. There's only the right tool for the specific thermal and structural environment you're building. Today, we're stripping away all the marketing fluff to look at the raw engineering parameters that dictate exactly which tray you should spec for your next build.
Okay, let's dive right into this. We're going to use a really structured, analytical framework today. We'll cover our core differences, structure and load standards, data center applications, a 5-factor decision model, and finally, industry compliance.
All right, starting us off, Section 1, Core Differences.
The foundational contrast here really just comes down to architecture. On one hand, you've got wire mesh basket trays. These have an open structure built specifically for maximum ventilation. And on the flip side, perforated sheet trays rely on an enclosed structure made from much heavier sheet metal. Now, obviously, they both route cables, right? But their dimensional footprint, the base materials they use, and the available finishes, those dictate totally different operational capabilities when you actually deploy them into the data center.
Moving right along to Section 2, Structure and Load Standards.
Listen, if you're writing a procurement spec, there's one alphanumeric string you absolutely need to memorize, and that's IEC 61537. This is the international benchmark standard. Basically, it dictates the specific load classes and the extreme testing parameters that these cable tray systems absolutely must survive. It serves as our global baseline. Whether you're building out a massive facility in Silicon Valley or Shanghai, this standard is what ensures the physical integrity of your routing systems just won't fall under pressure.
So, drilling down into IEC 61537, we primarily look at load Class A for lighter duty runs, while Class B scales way up for heavier duty requirements. The crucial point here is that when you're planning those critical cable runs right above your server racks, you aren't just picking a shape that looks nice. You are calculating the exact weight per meter of your copper and fiber, and you've got to ensure your selected tray hits that corresponding IEC load class. It's all about the math.
Which brings us to the real meat of our discussion, Section 3, Data Center Applications.
Now let's put these two head-to-head. What's really interesting here is seeing how these operational metrics diverge in the real world. Wire mesh trades away a little bit of load capacity to give you maximum airflow and really rapid installation. Meanwhile, perforated trays, they sacrifice that airflow and installation speed, but they deliver superior load capacity. This right here is exactly why you see specific trays dominating specific zones in your facility.
Let's laser focus on wire mesh for a second, because in a data center, thermal management is literally everything. The open architecture of wire mesh allows for absolute maximum airflow. Think about it. When you're running extensive overhead pathways through hot aisle containment systems, a solid or highly restrictive tray basically acts like a thermal dam. It just traps the heat. Wire mesh eliminates that dam altogether, which directly lowers your cooling costs and massively boosts overall facility efficiency. It's a total game changer for thermal dynamics.
But, we really have to counterbalance that with the engineering reality of the perforated tray. Because what happens when you've got an absolutely massive, super dense convergence of thick power cables or just sprawling copper network bundles? That's where the perforated tray shines, providing superior structural rigidity. It is not going to sag under high physical stress. When sheer load capacity is your absolute primary concern and your thermal dynamics are being managed somewhere else, well, the perforated tray is undeniably the correct engineering choice.
All right, let's turn this into an actionable strategy. Section 4, the 5-factor decision model.
So here's how you build a comprehensive procurement strategy that you can actually use. You've got to weigh these 5 interconnected factors together. Number 1, cable fill. Just how dense and heavy is that bundle going to be? 2, environment. Are we talking about a pristine data floor or a dusty industrial plant? 3, airflow. How critical is your overhead heat dissipation? 4 is budget, and you have to factor in both the material cost and the installation time. And finally, 5, standards compliance. Are you meeting code? You balance these 5 nodes and I promise you, the right trade type will just reveal itself.
And speaking of standards, let's wrap up with Section 5, Industry Compliance Summary.
Now, looking at manufacturer data from Xinma, and they produce everything from busways to seismic bracing, they state super clearly that their solutions comply with IEC 61537, NEMA VE, BSEN 50085, and GB 31251. Seeing a rigorous cross-border compliance list like that is exactly what we as engineers need to see to confidently specify a product for global, mission-critical infrastructure. It just gives you that peace of mind.
Which brings us to the end of today's explainer, and I want to leave you with one final kind of provocative thought. Next time you're on the floor, look up at your overhead racks. Based on the thermal dynamics and the load capacities we've just unpacked today, is your current cable management system actually suffocating your servers? It's absolutely a critical question worth investigating. Thanks so much for joining me for this explainer. Keep building smart, and I'll catch you next time.